All right, so if you look at A, it's definitely not smiling or frowning, so it's definitely going to be an odd degree. It is backwards, normally x cubed, and I call that the parent function. X cubed normally goes up on the right and down on the left. This is flipped around, so this is going to have a negative coefficient. One of the things they like to ask is about intervals of increase and decrease, and it's something that we did talk about in the beginning of the year, but it's been a while. So you read a graph from left to right. So if you were to tell a story, right, imagine there's a bird right here. The bird is going to fly down and then up and then down again. So I want to know at what points was a bird flying up. And we always use x values to tell the story. So it looks like between -1 and 1 is when the bird was flying up. So that's going to be the interval of increase. Any other intervals must be intervals of decrease. If they're not increasing, that means they're decreasing. So the bird began by flying down until it got to -1. Then it flew up, and then it flew down again right about -1, and it just continues. So the far left to -1, and then it picks up again at 1 and to the far right. So there's actually 2 times where that bird is flying downhill. For letter E, when they ask for domain, they mean how many x values are on your graph? What's the range of x values? And the good news is it's always going to be -infinity to infinity. It continually moves forever towards the left. It moves forever towards the right. There's no stopping points. So it's just going to be all reals. And then range means, hey, what's the highest point? What's the lowest point? Well, there is no lowest point. It goes down forever and it goes up forever. So the range is the same as the domain. And that's going to be true for all odd powered functions. So anytime you have an odd polynomial or you have an odd degree, you're going to have the same domain and range. So letter B, again, it's not symmetric. It's not frowning or smiling. It's doing a little both. So it is going to be an odd power, or an odd degree, I should say. However, even though it looks weird in the middle, if you think about x cubed goes up on the right, down on the left, and that's exactly what this is doing. So it is a positive leading coefficient. So it's like the graph of positive x cubed. It looks like if we were to tell a story about a bird, the bird flies up, down, and then up again. So we have 2 intervals of increase. We have from the very beginning on the left, which is -infinity, and it's going to continue flying until right about -2.5. And then it's going to fly downhill right until about here. Once it hits this spot, it's going to fly uphill. So we're going to have to estimate maybe like -0.3, not quite -0.5, but close to it. And it's going to continue flying up forever and ever. So it would fly down. If it goes up, it goes down between these x values, -2.5 and -0.3, and that's when it changes course. The domain and the range are going to be the same for every cubic, and then we'll try 2 more. So you can see that even though there's stuff in the middle, it is overall a smiley face. So it is definitely going to be even, and if it's smiling, it's positive. So people usually do better with the even guys because of the thinking of smiling being happy. It looks like it begins by going down and then up and then down and then up. So I said up twice. The question is, when does it change to going up? It looks like the bird will fly up between -1/2 and 0, and it'll fly up again between +1/2 and forever. So that must mean that it began by flying down right until that -0.5. And then it was down again between 0 and 0.5. So that's when you see the graph getting lower. The domain is going to be continuous, so it never stops moving left or right. gets taller, but it's going to continue moving that way forever. There's no stopping points. However, the range, we don't have a highest point because it goes up forever. There's arrows pointing up here, but there is a lowest point on this graph. It looks like it's about negative 0.5, very close to it. That looks like the lowest point on the graph. And remember, when we do range, we use y values because we're talking about height. So the lowest point on the y-axis of this graph would be about negative 0.5. And it just goes up forever, so we just say to infinity. For letter D, really, really nasty graph, but it is overall frowning. So it isn't even. Frowning means negative. Lots of increase and decrease. So it begins by increasing and then decreasing, increasing, decreasing, increasing, decreasing, increasing, decreasing. So lots of intervals. So something I like to do just to kind of help myself stay on track is I just put a plus sign where I see increase and a minus sign where I see decrease. So I want all the intervals where I see increase. So it'd be all the way from here to here. It would be from here to here. It would be from here to here. Not quite there. Maybe made that a little too long. From about right here to right here. And then it picks up again. It increases from here to here. So there's 4 intervals of increase. So it moves uphill from negative infinity and stops at negative 3. It picks up again at negative 2, and it increases until x is negative 1. And then it picks up again at 0, and it increases until x is 0.5. And then one more time, it picks up at 2 and increases until you get to 3. So what you want to do is make sure you're always using x values when you're talking about the intervals of increase. So it increases between here and here. So all the opposite intervals are going to be your decrease. So we have between negative 3 and negative 2, negative 1 and 0. See it going downhill between negative 1 and 0. It goes downhill again between 0.5 and 2. And it goes downhill again from 3 to infinity. Our domain is going to be all reals because it never stops moving, it never stops flowing from left to right. But we do have a highest point this time at 1. So the highest point is 1 unit high. There is no lowest point, so our range expands to negative infinity.